Hello and welcome to my channel. In this video, I will be explaining you about Wittig reaction. But before beginning with this, I would like to say that do not get confused with Wittig rearrangement. Both Wittig reaction and Wittig rearrangement are totally different thing, but both have been developed by the same scientist, Mr. Georg Wittig. So let's see what this Wittig reaction is. So this Wittig reaction is also known as Wittig Olefination reaction, which is a chemical reaction between an aldehyde and a organophosphorus compound, which is also called as halide, and it generates corresponding substituted alkene. So reaction involves substitution of carbonyl oxygen atom with an alkylidene group, and it can be performed in presence of base such as phenyl lithium and solvents like THF, DMSO or DMF. Let's see its general reaction. So we take an aldehyde or a ketone and we treat this with phosphorus halide in presence of base and THF as a solvent. So during the reaction, this oxygen atom will be replaced by alkylidene group and we get highly substituted alkene along with triphenylphosphine as the byproduct. Let's see its mechanism. So the mechanism involves two steps. Step 1 is halide preparation, which again involves two steps. First, nucleophilic substitution of an alkyl halide with triphenylphosphine via SN2 mechanism, and then treatment of phosphonium salt with a strong base like phenyl lithium or sodium ethoxide to give halide via loss of proton. So this is the mechanism for preparation of phosphorus halide, where we have triphenylphosphine. The lone pair of electron on phosphorus is the driving force for this reaction. So this attacks on this alkyl halide, generating alkyl triphenylphosphine halide. Then we treat this alkyl triphenylphosphonium halide with phenyl lithium base. Base will abstract this proton, thereby generating a negative charge on carbon atom. So this is phosphorus halide. If I shift this negative charge from carbon electrons between this carbon and phosphorus, we will get double bond. So these are the two resonating structure for phosphorus halide. So this is how we prepare phosphorus halide. Once it has been generated, then we perform reaction of halide with carbonyl carbon. So this again involves two steps. First is butane intermediate formation, which changes into 4-membered oxaphosphatane ring, and then finally this ring opens up to generate highly substituted alkene via elimination of triphenylphosphane oxide. So this is our aldehyde or a ketone, and this is the phosphorus halide which we prepared in step 1. So the driving force is negative charge of electron on this carbon atom. This will attack on electron deficient carbonyl carbon, thereby generating a negative charge on oxygen. So we get a butane intermediate where you can see there is negative charge on oxygen and positive charge on phosphorus. So this negatively charged oxygen will attack on phosphorus so that this charge is neutralized, and we get a 4-membered ring containing phosphorus and oxygen atom. This is called as oxaphosphatane ring. Since this ring is very small, so it is highly strained, so the molecule will try to get stabilized, and phosphorus has got greater tendency to form bond with oxygen than carbon atom. So due to this, the ring will open up, thereby generating highly substituted alkene along with triphenylphosphine oxide. Let's see examples of Wittig reaction. So here I have taken benzophenone and treated with phosphorus halide. You just have to replace this oxygen atom by this alkylidene group. So we get a tetraphenyl ethene as the product, which is a highly substituted alkene. If we take cyclohexanone and treat that with the corresponding phosphorus halide in presence of phenyl lithium as the base, then oxygen will be replaced by alkylidene group to generate highly substituted alkene. So I hope you like this video. Please like, share and subscribe. Thank you so much.